International Physics Olympiad year 1984 IPHO. Problem number 1. Question A. Consider a plane parallel transparent plate where the refractive index n varies with distance z from the lower surface. See figure shown. Show that NA multiplied by sine alpha equal NB multiplied by sine beta. The notation is that on the figure. Question B. Assume that you are standing in a large flat desert. At some distance you see that appears to be a water surface. When you approach the water, it seems to move away such that the distance to the water is always constant. Explain the phenomenon. Question C. Compute the temperature of the air close to the ground in B, assuming that your eyes are located 1.6 meters above the ground and that the distance to the water is 250 meters. The refractive index of the air at 15 degrees Celsius are at normal air pressure 101.3 kilopascal is 1.000276. The temperature of the air more than 1 meter above the ground is assumed to be constant and equal to 30 degrees Celsius. The atmospheric pressure is assumed to be normal. The refractive index n is such that n-1 is proportional to the density of the air. Discuss the accuracy of your result. Solution for question A. Consider a plane parallel transparent plate where the refractive index n varies with distance z from the lower surface. See figure. Show that NA sine alpha equal NB sine beta. The notation is that of the figure. According to Snell's law, we have for one surface between two layers is this formula. Now we can split our plate by infinitesimal layers with a constant coefficient of refraction, and for each border we can write Snell's law, which give us this sequence of equations. So finally we have then NA sine alpha equal NB sine beta, which is a solution for question A. Question B. Assume that you are standing in a large flat desert. At some distance you see that appears to be a water surface. When you approach the water, it seems to move away such that the distance to the water is always constant. Explain the phenomenon. Solution. The phenomenon is due to total reflection in a warm layer of air when beta equal 90 degrees. This gives us NA sine alpha equal NB. That was solution for question B. Solution for part C. Using information that n-1 proportional to density and density back proportional to temperature, we have n as a function of t equal 1 plus some kind of coefficient k divided by temperature in kelvins. Now, using information that for temperature 15 degrees Celsius we have coefficient of refraction n equal this one, so we can count that k equal n-1 multiplied by temperature, or 0.0795. So now we can use equation that N for 30 degrees multiplied by sine alpha equal N for temperature close to surface. We have sine alpha equal L over square root from L square plus H square. And now we have equation. This one, from which we can count what is the temperature near the surface. That will be this one. Here we use knowledge that H over L is very small. So it means that here we can use approximation and find finally that temperature T equal 328 kelvins or 55 degrees Celsius. This is the answer and the solution for question for part C. And here we solve all problem number 1.